Okay, problem number 4 on assignment 20A. Got this little curve, it's the line and the semicircle, and that's f prime. They also told me that f of 0 is 3. It's going to come in handy in just a little bit. When is the function increasing? So whenever I hear increasing, I think derivative. If the function is increasing, the derivative must be positive. This is the derivative. So the derivative is positive only here and here, right? So from -3 to -2. It's a little bit unclear if that should be an open parentheses or closed. It doesn't really matter, but it's from -3 to -2. Part B says find the inflection points. Justify your answer. So again, forget about the picture. Just think inflection points means second derivative equaling 0. So I put inflection points occur when the derivative second order 0 maybe, because remember those are just our starting point. We still have to check to make sure the signs are changing there. They might show up as critical points, but then those signs might not change. So I want to know when the second derivative is 0. So the second derivative is 0 or undefined, sorry, missed that point, 0 or undefined. So that second derivative are the slopes of this problem right here, right? This is the first derivative, so I'm looking for the slope. So I want to know when the slopes are 0 or undefined. So there's a 0 slope right here at 2. There's also an undefined slope right there at 0. So 0 and 2 are my possible inflection points. So now I need to just make sure they really are inflection points. So then I do my little number line, and then I remember I'm plugging into the second derivative, which are just slopes. So before 0, this is the first derivative, so the second derivative are their slopes. So negative slopes, positive slopes, positive slopes, negative slopes, negative slopes, negative, positive, negative. So it is changing at both of those. So they're both inflection points. Your reasoning, when they say justify your answer, this doesn't work. You need to say what you're saying. So the second derivative is changing signs, which is making them inflection points. Part C asks you to find a tangent line at the point 0,3. So I'm 2/3 of the way there, I guess. I got the point. All I need is the slope at 0,3. This is the slope, yeah. I'm sorry, slope at 0. X equals 0, so I just go to 0. That slope is right there. It's that point, because this is the slope. Not the slopes of these. This is the slope, f prime. So the derivative is -2. So it's y minus 3 equals -2 the slope times x minus 0. And the last question now, we've seen these sorts of questions a few times. They're a little tricky. It says find f of -3 and f of 4. So I don't have the function. I'll never get the function because I don't know anything, right? I just know the picture of the derivative. Although I could get it here because I could probably make an equation of this line. I could make an equation of that circle and find those equations, but that's a lot of work, and then find the antiderivative. But remember that if you integrate, so they asked me to find f of -3. I know f of 0 is 3. So I'm going to use 0. That's why I'm using 0 here. I'm going from -3 to 0 of f prime. So if I were to integrate f prime, I'm going to get f. So this integral is going to be f of 0 minus f of -3. That's going to be that integral. The thing is, I know what that integral is because it's just area under a curve, right? So I come back up here. That's that number. You can see -1/2. It's just from a -3 to 0. Where's the -3? That's this triangle. And that triangle added together, it's going to give me that -1/2. So f of 0 minus f of -3 is -1/2. And I know what f of 0 is. It's 3. And then I just solve for f of 3. And I get 4.5. And the same thing on the other one. It's the same exact problem. Not quite sure why they ask you twice. This time I'm just going to integrate from 0 to 4 of f prime. It's going to give me f of 4 minus f of 0. So I got to find this area. So that's this number. It's that area and that area. It's a rectangle, 8 units, 4 by 2. And then a semicircle, right? So it's a semicircle with a radius of 2, so it's 4 pi, so that's the 2 pi. But remember, it's underneath the x-axis, right? So my first thought was, okay, it's 8 minus 2 pi. But then it's the opposite of that because it's underneath the x-axis, so it's -8 plus 2 pi. And again, that has to equal f of 4 minus f of 0. So we've seen this problem quite a few times. It's a pretty common way to find functional values, even if you don't have the actual derivative, by using the areas under the curve. Same thing with, we did this with velocity in a couple of the other problems. So that's it on that one.